Today, we're going on one of the most incredible journeys imaginable. Not to some distant star, but into the space between our own ears. A project between Harvard and Google has just given us a map of the human brain like we've never seen before, and it really makes you wonder. It's a wild thought, right? We've got these unbelievable telescopes that can see to the edge of the universe. But the thing sitting right inside our own skull is still, in many ways, a complete mystery. And the reason for that all comes down to scale. The real action in the brain, the stuff that makes us, happens at a level so tiny it's almost impossible to see. Sure, we've all seen brain scans like MRIs, and they are amazing. They show us which big neighborhoods of the brain light up when we're happy or solving a puzzle. But what they can't do is show us the actual streets and houses. They can't see the individual wires, the synapses, where all the information is actually passed along. And that's where the code of consciousness is written. To actually read that code, you have to zoom in. Way in. We're talking nanoscale. We need a map that shows every last wire and every single connection. And for that, you need a totally different kind of tool, an electron microscope, which lets us see things that are smaller than a wavelength of light. And that brings us to the HO1 project. This was this massive effort to finally create that map. A team from Harvard and Google got their hands on a tiny piece of human brain tissue from the temporal cortex, and they set out to map every single thing inside of it. And when I say tiny, you won't believe how small it was. The whole sample was just 1 cubic millimeter. That is about the size of a single grain of sand. Now, it came from a patient who was having surgery for epilepsy, which is an important detail, but pathologists confirmed the tissue itself was structurally normal, which means this is the clearest, most detailed look we have ever had at our own wiring. Okay, so what's inside that grain of sand? Well, for starters, the team found over 57,000 individual cells. You've got your neurons, your glial support cells, blood vessels, the whole shebang. It's like a whole city packed into this microscopic space. Just let that sink for a second. But here's the number that just blows my mind. The synapses, the connections. Inside that 1 cubic millimeter, they counted nearly 150 million of them. These are the little junctions that make the whole circuit work. 150 million connections in a piece of brain you could barely even see. So, what kind of hard drive do you need to store a map of a single grain of sand's worth of brain? Well, it turns out you need 1.4 petabytes. To give you some perspective, 1 petabyte is 1,000 terabytes. This data set 150 years, all for that one tiny speck of tissue. So the big question is, how on earth did they do it? Creating this digital universe from a grain of sand was an unbelievable challenge. It took a mix of super precise biology, powerful microscopes, and just a massive amount of computing power. It was like trying to solve a puzzle with trillions of microscopic pieces. Here's the basic idea of how they pulled off this incredible feat. First, they took that tiny sample and sliced it into more than 5,000 slivers, each one thinner than a wavelength of light. Then, a custom microscope took pictures of every single slice, creating millions of little image tiles. After that, some seriously powerful software had to stitch all those millions of images together into one solid 3D block. And then came the really amazing part. They unleashed AI algorithms to trace every single cell through that entire digital maze. And this slide just shows you how tricky that alignment step was. See the images on the left? That's the raw data. It's all shaky and misaligned, like a messy stack of photos. But on the right, after the software works its magic, you get this perfectly smooth, continuous block of tissue. Now just imagine doing that for 196 million pictures to build that final 1.4 petabyte model. It's just incredible. Now this is where the AI becomes the hero of the story. You see, trying to trace 57,000 cells by hand through thousands of images would be, it would be impossible. It would take centuries. So they used this clever AI called a flood-filling network. You can see it working here. The black and white image is the raw microscope data, and the colored parts are where the AI has automatically identified and filled in each cell, creating a perfect 3D model of everything inside. Okay, so building the map was a technological marvel, but the real excitement, the reason they did all this, is what they found inside. This map is so new and so detailed, it's already rewriting textbooks and showing us things we've never ever seen before. Let's check out some of the highlights. So first off, just taking a basic count head of what's in there led to some big surprises. For one thing, the brain support cells, the glia, actually outnumber the neurons 2 to 1. And get this, the most common type of cell wasn't a neuron at all, but something called an oligodendroglade, which makes the insulation for the brain's wiring. Oh, and they also found a bunch of weird blobs that they couldn't identify at all. But then things got even weirder. Deep down in a part of the cortex called layer 6, they found these bizarre neurons. Take a look at the image here. They call them compass neurons. See how they each have one really big branch that points in one of 2 opposite directions? They form these perfectly mirrored groups. What are they for? Right now, nobody has a clue. This quote is pulled straight from the scientific paper, and it hints at what might be the most profound discovery of all. The scientists started noticing that some of the connections in the brain didn't look random at all. They looked like they were there on purpose. And this is exactly what they meant. So most neurons connect to each other with maybe 1 or 2 synapses. It's a pretty weak link. But the team found these rare, incredibly powerful connections. Check out the image here. You can see a single axon reaching out and making 53 separate connections to one single partner neuron. The odds of that happening by chance are basically 0. It suggests the brain isn't just a random web, it's deliberately forging these super connections between specific partners. So after years and years of work, this first incredible exploration is done. But here's the best part. This isn't the end of the story. It's really just the beginning. Because the team behind this map didn't just publish their findings and call it a day. They did something much, much bigger. They've made the entire thing, all 1.4 petabytes of it, totally free and available for anyone in the world to explore online. They even built tools so you can fly through it yourself. This isn't just a research paper, it's a new atlas for neuroscience. It's a gift to science that's probably going to lead to discoveries for decades. And that just leaves us with this final, kind of humbling thought. This entire journey, all of these wild discoveries, came from a piece of our brain no bigger than a pinhead. So it just makes you wonder, what other beautiful, bizarre, and unimaginable secrets are hiding in the billions of other millimeters that make up the rest of the human brain?